So one thing we haven't talked about very much is the tangent graph and what that looks like. This isn't necessarily in your notes, so if you want to take your notes, you can. What I did was I filled out the unit circle, all the points all the way around the unit circle, and filled in the tangent. We've been concentrating for our parent graphs at 0 pi, half a pi. Notice what happens with tangent when we do y over x. Pi, 3/2 of pi, and 2 pi. The tangent graph isn't quite as simple as the sine and cosine graph because we have some undefined parts. We have undefined at pi over 2, which means that's an asymptote. It has no value. We also have another undefined at 3 pi over 2. That's another asymptote. The other points that we do know is at pi. We know at 0 pi and at 2 pi, they're all 0. And then we have some turning points. If I go up to 1 and -1, I know that at pi over 6 it's a little over half. Then it's at 1, and then it goes up to 1.7. And what the tangent graph does is it turns and twists and hits the asymptote. And then if I keep going at 2/3 pi, I'm way down here again at negative, and it twists and turns, and then it goes to this asymptote. And the tangent graph, and maybe try it on Desmos or on your graphing calculator, but what it does is it twists and turns, and it has all these asymptotes over and over and over again. So this is a quick example of what the tangent graph looks like, but let's talk about the important key parts. Now, when is the cycle done? Well, if you look here, this is at half a pi, and this is at 3/2 of a pi. So how long did it take to complete one cycle? It's only pi long for its period. Now, we do not have an amplitude because this continues to go on and on. Instead, we have what are called turning points. And the turning points are the points in which this twists and turns. It happens still at 1 and at -1 for now. So we're going to say that this one happens at, and I'm going to go back here to my origin and do it this way. This is at -half pi. So again, my period is still a pi long, but my turning points happen then halfway. So it happens at -1/4 of a pi, -1, and +1/4 of a pi, +1. These are now my big turning points. The domain now does go on forever and ever and ever. However, this time we have asymptotes. And the asymptotes happen every single time that we hit a half of a pi. So you can list it from -infinity to +infinity, but it does not include half a pi, both positive and negative. The range also now goes from -infinity to +infinity because it goes on forever and ever down and forever and ever up. So it's just a little bit different than the sine and the cosine wave. So if you did not fill in just the basic tangent graph, I'm going to quick do that with you again. So we have -pi/2 and +pi/2. We have our turning points at 1 and -1, and also at 0, 0. These are where our asymptotes lie. So it curves up and twists, and it curves down and twists. That would be your basic parent graph. Again, the period is pi. There is no amplitude. We're going to concentrate on turning points. and those happen right now at negative pi over 4, negative 1, and positive pi over 4, positive 1. My domain is all real numbers except for positive and negative pi over 2, or you can list it like I did earlier with negative infinity to positive infinity, except for half a pi, and there is my range. Okay? This second one we're going to rewrite as tangent of 1/2 over x. And this still is our A, B, C, D. This is B, and B affects period. Now, period usually equals 2 pi over B, but now period equals 1 pi over B, because the period in tangent is only 1 pi. So what is pi divided by 1/2? Multiplied by the reciprocal, and this time my period is going to be done in 2 pi. So think about these asymptotes were a pi apart. Now they need to be stretched to 2 pi apart. So what I'm going to do is stretch. I'm going to make this 0, 0 right here. It's going to make a lot more sense if this is 0, 0. Okay? So instead of a half a pi for my asymptote, my first asymptote is going to be at pi and at negative pi. There is a period of 2 pi now. My turning points are halfway. So they were at 1/4 of a pi. Now they're going to be at 1/2 of a pi and negative 1/2 of a pi. My amplitude, or A, does not change. So this is still 1 high and 1 low. So it's going to twist and turn this way, twist and turn that way. So my domain this time is all real numbers, except it does not include all of the pi's. And then, like, you could list the second one, which would be pi over 3. Range is negative infinity to positive infinity. My amplitude technically is 1, but the turning points happen now at negative infinity, or negative 1/2 pi, negative 1, and positive 1/2 pi, positive 1. Okay? All right, let's jump to example number 4. Again, everything that we're doing, you should be able to tell me. What is a negative A going to do? It's going to flip it, and it's got an amplitude now of 3. B is pi, so period equals 1 pi over B. This time my period is 1 pi divided by 1 pi, or 1. So my period is 1, my amplitude technically is 3, but again, we're going to be focusing on turning points in a second. I'm going to move my origin here in the middle. And if my period is 1, we need our asymptotes to stretch 1 apart total. So this is going to be 1/2 and negative 1/2, which means my turning points are going to be at negative 1/4 and positive 1/4. Now, here's the difference. The amplitude was at 1, now it's at 3, and it's at negative 3. So think about how that's going to flip or reciprocate. It used to look like this, but now it's going to come over this way instead. So we're going to take this and twist it, and take this and twist it. So my turning points now are at negative 1/4, positive 3, positive 1/4, negative 3. My domain now is a set of all real numbers except for halves. So plus or minus 1/2, a whole, period after that would be plus or minus 3 halves, and so on. And my range is from negative infinity to positive infinity. Okay? See if you can finish the rest of them on your own.